Hello everyone. So we'll start our discussions associated with the Jupyter Notebook, as I had mentioned in my last live session uh, through this uh, through this pre-recorded video. So I'm assuming that all of you have already uh, installed Anaconda, and the way that we are going to start is by assuming that you are an absolute beginner. Uh, so let's first start uh, firing up Jupyter Notebook. And the way that I prefer to do it is, so I'm using Windows 10, that's my operating system. So I just go to the start button and you can already see that some things related to Anaconda are already available here. Okay, so what one would do usually is to go to this Anaconda navigator, click on that, and then it will take some time for that graphical user interface to pop up, and then you would click this and that to go into it. However, what I prefer is to actually use the Anaconda prompt. Okay, so it gives me a direct way of going to a certain drive and launching the Jupyter Notebook as that as my root. Okay, so if it doesn't make sense what I'm saying, I'll just demonstrate in a minute. So what you do is here in this search bar, you just write Anaconda prompt. Okay, so when this pops up, we click on this, and this kind of a command window it appears. And by default, if you are if you have not done anything too adventurous with your settings, so this kind of a thing, the basic, the default root should come up like this. Okay, we don't want to be using the same drive in which our operating system is installed. Rather, my working drive is a separate E drive, so I'll change to that. Okay, so I've changed over to my E drive where all my teaching folders are present. So what I'll do is I'll launch Jupyter Notebook from this root. Okay, so it's as easy as just writing Jupyter Notebook with a space in between and then pressing enter. So when I press enter, what it will do is it will open up the Jupyter Notebook interface as a separate tab in the browser. Okay, so the Jupyter Notebook, if you want to call it like a software, all the visualizations and everything, it takes place as a tab in your browser, of course. And that does not mean that it is like an internet based or a cloud based thing. It is very much native to your local machine, to your local computer, but still the visualizations take place as if it is a net file. Okay, but it is not. Okay, it is very much local to your system. Okay, so let's press enter, and hopefully the yes. So we go to the appropriate place. So this will be something specific to your system. Okay, so I'm teaching two courses this semester, Elasticity and Mechanics of Solids. Of course, we are going into Elasticity. All right, and I have already set up one folder there, Jupyter Notebooks. So we go into that, and one specific folder. So what I'll do is, as you can see, I've already created some files before this recorded video, and I will not open any of those. Okay, rather I will just since this is meant for beginners, what I will do is I'll just open up a new file, because that is exactly what you will be doing. Okay, so we go to this new thing. Okay, click on this, and there are a number of options here. We want to open this Python 3. Okay, so we click on this and a separate tab opens. Okay, so you think of it like this, that this new tab that has opened, which by default is called that's named as the untitled. Okay, just like any other file. So this is a separate tab from this original tab. Okay, so this was like my navigation kind of thing, and this is the actual Jupyter Notebook file that we have opened up, and this is where we are going to do our work. Okay, so since this is meant for beginners, let's try things start out in a very simple fashion. So as I had mentioned in passing during one of my live sessions earlier, we don't actually have to write full-fledged code here. Okay, so we can just use it almost like a calculator. So very basic. So 2 plus 2, let's say. Okay, now if you just press enter, okay, so I'm just pressing enter now. You see it just goes to the next line. It adjusts the whole box and it just goes to a new line. It doesn't show me the result. So let me just backspace, and what I need to do in order to obtain my result is to do a shift enter. Okay, so I press the shift, and after with the shift key pressed, I will press enter. Okay, so shift I have pressed and then enter. So now it gives me the output. Okay, so that's nice. So as you see, this first cell, okay, so these boxes, these long rectangular boxes that you see, these are like the cells. Okay, these are called the cells, and this is the input cell. Okay, so as you can see, it is called in1. Okay, so this is the designation for the input cell number 1, and this is the output cell number 1. Okay, so similarly we can keep on doing various things in the various cells. Now so just for the kick of it, let's do something else, maybe 4 into 8, just to show. Okay, so when you get the idea, you can do whatever you want. Now you have to note something, that why are we actually using this Jupyter Notebook? Okay, so whatever I'm doing here, I might as well have done from a command prompt. Okay, what I mean to say is that if you are somewhat familiar with the classical way that programs are run, so you would open up an editor, you write some lines there, save it as a file, maybe compile that in a separate thing, or maybe use some kind of interactive development environment and do those things. But we're not doing that. We have picked up Jupyter Notebook, not just because it's kind of stylish or something like that, rather because the visual output as it is presented as a browser tab is very appealing, and it will this sentence that the visual output is very appealing, it will make much more sense, and you will appreciate it more as we go forward and do symbolic calculations. That's the idea here. Okay, but apart from that that appeal of the nice visual output, another important thing is that this Jupyter Notebook, it allows a very nice way of putting in comments. Okay, so if you are familiar with any other programming language, you know that using some special symbols, you can mark out some lines of code as commented lines. Now what we can do here in Jupyter Notebook is to write full-fledged descriptions. Okay, and this makes it particularly suitable in a teaching kind of environment, in a teaching learning kind of environment. It is also very useful for making reports where the description as well as the working out of your ideas, it is present in an integrated fashion. So let me describe what I'm saying. So see, this is like a very simple calculation. This is a very simple calculation, but you see, when I'm clicking on this description here it's a code. Okay, of course it's not like a full-fledged code, but it's some calculation. Okay, in that sense it's a code. So there is no description here. I'm not saying that I am adding 2 plus 2. I'm not writing this sentence here. Also I'm not writing the sentence that 4 into 8. Okay, I could. Okay, so suppose adopting the syntax for putting in comments in Python, we can use the hash symbol and putting in lines that here we multiply 4 and 8. Okay, we could do that. Okay, of course it's meaningless here, but we could do that, but it would as our computations and calculations become more involved, it will make much more sense to write a full-fledged description of our ideas. And to do that, what we'll do is we'll use these cells. Okay, this cell, for example, this fresh cell where I have not put anything in, that itself as a comment, okay, or as a some kind of a sentence, full-fledged English sentence. And the way that I can do it is I can click on this thing. So I hope you can see my cursor here. So I click on this and you see there are a number of options here. Okay, so what I will choose here is the Markdown option. Okay, so you see this line itself has changed. It is no longer described as an input. Okay, because this is going to be now a Markdown thing. So Markdown is basically, you can Google Markdown. It's a very easy way of writing text, but with some added benefits. Okay, and as we go along, you'll see the benefits. We can put nice links and everything. In fact, the website that I'm maintaining for our course, the raw files for that I actually write in Markdown and then I convert it to HTML. Okay, it's much easier that way. Okay, so for example, next, subsequently, if I want to add two numbers. Okay, so let's say I want to add a equal to 2 to b equal to 3, and then I want to store the result in C as a plus b. So this is a very simple thing, anybody can understand it, but for the purpose of demonstration, let me just show it. All right, so what I will do here is that I'll actually write down the comment, okay, and you'll see how visually appealing this is also. So, so in the next cell, we want to add a equal to 2 to b equal to 3. Okay, now you see here I have put this a equal to 2 within the $$ symbol. Now that is, so this part within the $$, so that is basically telling it to mark it out as a LaTeX thing. Okay, so as a LaTeX input. So LaTeX is basically one of the oldest and most powerful typesetting environments, and all the typeset notes that I provide to you as part of the Applied Elasticity course, that I do in a full-fledged LaTeX environment. Okay, so the good thing about this Jupyter Notebook is that it allows Markdown input, and within Markdown it allows us to input the LaTeX input also, and that makes the mathematics presentation in a very nice and clean fashion. Okay, so let's demonstrate. Okay, so in the next cell we want to add a to b and then store the result in C, in the variable C. Okay, now see here I have told you, in order to get the output of a cell, I need to press Shift Enter. So similarly here, okay, so I press Shift Enter. Now you see whatever I had typed in, it gets rendered in such a nice fashion. Okay, I hope you can see this. Okay, so it's a nice properly typeset thing. Okay, and if I want to go back and edit it, I can just click on here, click again. So I have to double click actually, and I can edit this cell. So for example, I can just so this is a Markdown cell. It allows LaTeX input also. All right, so let's actually do this. In the next cell, we'll write a equal to 2, b equal to 3. Please note that when you discuss, or when you write this comment that a equal to 2 and b equal to 3, that is just like a comment. It doesn't get stored anywhere. Okay, it doesn't do any maths actually. The maths part actually has to be done in a separate cell, which is marked as a code cell. Okay, not as a Markdown cell. So if you go to the previous one, you see this is a Markdown cell. Here this is a code cell. The previous one also was a code cell. The previous one also was a code cell. So all these are code cells. So we store a equal to 2, b equal to 3, and then we say c is equal to a plus b. Okay. Now if I press Shift Enter, you see nothing happened. Well, nothing happened because we did not actually display C. So we'll do that. Okay. Now, till now we have not done anything to do with symbols. Okay, so let's try to do that. So for that, what we'll do is we'll have to first import the symbolic package. Okay, the symbolic Python package. So in Python, the base Python, we do not have the symbol, nor do we have the numerical computations package. So we have to import all of this whenever we need them. So what we can, there are a number of different ways of importing packages. So the way that I prefer to do it, and which is also standard advice, is that we import this package, and you actually have to know the name of the package. Okay, so the name of the symbolic Python package is SymPy. Okay, some people call it as SymPy. I call it as SymPy. Okay, so we could do this, import SymPy, but what I will do is I'll put in a little extra decoration here. Well, it's not a decoration; it has a meaning. But for now, let's not get into the nitty-gritties of all of this. Okay, so why I am writing this as sim or something. So as sim, so this sim, okay, it is purely my choice. Okay, so let's do a shift enter. So you see this asterisk, it showed up for some time. It meant that it was loading. Okay, it took some time to load. So depending on your computer, it may take a little bit more time, a little bit less time, whatever. Now, as I was mentioning, this same thing, it's completely your choice. Okay, you can write it as import SymPy as same, import SymPy as SP, import SymPy as rabbit, import SymPy as tiger, whatever. Okay, doesn't make any difference, but of course there are some idiomatic practices within the Python community. So it's more or less standard that we write it like this. Some people write it as SP. So in autumn 2019, I was using import SymPy as SP all throughout the course, but I think this is clearer. Okay, so SP is actually I think more standard way of importing the scientific Python package. Okay, so we'll reserve it for that if we ever need it. For now, all throughout this course, we are going to import the symbolic Python package as sim. All right. Now, so we have imported the symbolic Python package, and now we want to begin our demonstrations of that, because that is what we are going to use the most in the rest of this Elasticity course. And you'll see that that use is going to make our life a lot easier, especially when we go into the long drawn algebra associated with 2D elasticity. Okay, so first things first, we have to define the variables x and y. Okay, so the way we do it is like this. So you have to know the syntax a little bit, okay, which is part of the learning. Okay, so as simple as that. So we press shift enter, and you see nothing happened. Well, nothing happened means it's good. Okay, so it means it did it. It has done its work, and now we are ready to begin using our symbols x and y. So without actually defining this kind of thing, without what I have done here in line, this input cell number 6, you cannot use. Okay, without that line, you cannot start writing x, y, or x plus y. All those things you cannot do. You have to first define them, and similarly for all other symbols. Okay, now what do we want to do first? Let's say, I mean, one of the easiest things that we could do is we can write something like x plus y squared. Okay, let's try to do that. X plus y squared. Please note that in Python you cannot use this caret operator. Okay, so let me just show you this caret operator, which you are probably more familiar with other programming languages. That is not going to work here. Okay, so you have to use this double asterisk. That is this the way that you use the power. Okay, similarly for x plus y cube, also you have to write double asterisk 3, or fourth power you have to write double asterisk 4, and etc, etc. Okay, so now if we do this, let's press shift enter. Let's see what happens. Okay, very nicely it has printed out x plus y whole square, but this is not what we wanted. Okay, we wanted the expansion of this. Okay, so what can we do? Well, uh, there is a way, literally we can use the expand command. Okay, so what we can do is, around this x plus y whole square we can put a bracket and then just write expand, but this empty parenthesis is very important. So let's see if we do this, what happens. So it took a moment there, but it has successfully expanded it out. Okay, now you may say that this is very trivial example, but let me just demonstrate the power of this to you. So let me just copy this previous cell and do this again, but now for the fifth power, which is not so trivial. Now you see, in almost the same time that took earlier, it has given me the output. Okay, let's go a little bit higher. Okay, let's go for 10, and now you see, okay, the convenience it allows us. So in order, I mean, if you had to do this by hand, that would have taken some time. Now let's really push it. Let's go 100. Let's see what happens. Okay, so it has taken a little bit of time, not to calculate it, but to render it. Okay, and you see, initially it had just printed it out in a single line which you could not see properly, but now this thing has actually been printed out properly. This entire thing, and it didn't take that long a time if you think about it. Okay, let me see if I can make this full screen. So I think this looks a little bit better now. Okay, you see, now this, there is no way you could have done that by hand, unless of course you're record holder in patience. Okay, so with that out of the way, let's look at some other things we can do with symbolic Python. Now you know that whenever we have to do some calculations involving pi, like the area of a circle, or something like an angle in radians, like pi by 3. So when writing it on a piece of paper, we can simply write pi, the symbol pi, and we all understand what it is. But if you have to make the computer understand as part of your calculations, so if you have some experience with programming languages, you know that you actually have to write it down as the value of pi. Okay, so maybe I think in MATLAB it allows you to write it like a pi. I think it understands it, if I remember correctly. Now what about the symbolic version of it? Okay, suppose we want to write it in a fashion that would completely mimic, okay, whatever we do on a piece of paper when writing by hand. Okay, so sim.py. Okay, so let's do a shift enter and see what it gives us. So you see this symbol is printed out, and this actually is quite meaningful. It is meaningful because suppose you want to extract the value of this pi, what you can do is you can use this kind of an operation. So symbolic.n means it's an instruction to extract the numerical value of a symbol. Okay, so what we can do is we can supply to it this pi symbol. Okay, so the instruction here is like this, that it's basically n of pi. Okay, the numerical value of pi. This sim is basically just to have a very explicit understanding that we are operating within the symbolic package, or we are using things from the symbolic package. So sim.py is the pi symbol, and sim.n is basically just asking it to extract the numerical value out of it. So if we do a shift enter, so you see it gives us the numerical value correct to how many decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, up to 14 decimal places. Of course, you can control how many digits it displays. So let's try to do that. Let's say we want to display uh, uh, three significant figures, not, mind you, not decimal places, but three significant figures. So see, 3.14. Okay, so if you had wanted up to the third decimal place, then you would have to write this as 4. Okay, so you get the idea. Now let's go a little bit crazy and do 100. Let's see if we can do it. See how quickly it gives us the value. Okay, okay, so can even go up to higher and higher. I mean, it's a non-terminating decimal, right? So it keeps on going, just keeps on going, no problem. And how fast it is. Okay, so let's just bring down our craziness a little bit. Okay, like that. Okay, uh, so that was good fun, but now let us get into the actual useful things we can do with symbolic Python. So let's say we want to solve two linear simultaneous equations. Okay, so what we'll do is, uh, again, I'm going to use the Markdown cell. Okay, so instead of a code, I'll write down the first Markdown description of it. Now this time, instead of clicking on here, I will tell you another way in which I can quickly convert using my keyboard itself this cell, which by default is a code cell, into a Markdown cell. So with this cursor blinking here, I'll just press escape. Okay, I'm just pressing escape. So you see this thing has now turned blue. Okay, and this cursor is not blinking. So I have like come out of the editing mode and now I'm in the command kind of mode. And now if I just press the letter M on my keyboard, M for Markdown. Okay, I'm just pressing M, no shift, nothing, just M. See, automatically it has turned into this Markdown cell. Okay, and now if I press enter, I have not pressed down on my mouse pad or anything. I'm just pressing enter. It has become a Markdown cell ready for editing. Okay, now if I want to convert this back to code, a code cell, again I have to press escape. It changes to blue, and now I press Y. See, it has changed to code. So I pressed the letter Y, Y for yellow. Okay, I don't know why they have chosen the letter Y, but it's their decision, people who made it. So this is a shortcut thing you can use. Okay, so when you are in the flow of doing your calculations, writing your reports and everything, these kinds of small tricks, it helps you stay in the flow, okay, and not break your flow. Anyway, so we want to convert this back to Markdown. So again, escape. So M, enter. All right. So again, I'm going to write a little description. We now want to solve two linear simultaneous equations. Just like in high school. And now we can actually exploit the power of the LaTeX input here. So if you're not familiar with LaTeX, don't worry about it. It's just a way of typesetting things beautifully. So I'll just write this down. This is not actually the point of this demonstration, but just to show that this can be done. Okay. All right. This will be useful for you when you want to write the report for your term project. Okay, for then it will be useful, these kinds of things, but for now you just concentrate on the code parts. Okay, so let's say we have this one of these equations and another equation. Let's say we have x plus y. So there was a bit of a power failure which is why I had to restart everything, and which is why you can see here that the input cell numbers and output cell numbers have changed, because I ran the entire notebook that I was creating again, and all the cells ran sequentially once, and so the numbers have changed a little bit. Okay, but other than that, everything else remains the same. Okay, so everything that I had typed earlier, it remains the same. So we'll continue from what I was discussing. So we have this thing. So I was writing like this, and if I shift enter, it displays these two equations. Now, as I mentioned earlier, so the previous one was a markdown cell, and I had just mentioned what I was going to do. So we actually have to do it now. We have to solve this linear simultaneous equations. So how do we go about doing that? First of all, we have to set up the equations themselves, and then we have to solve them. So symbolic Python actually has a command for that, for setting up equations, and what we'll do is we'll call our first equation as eq1. So this is the command sim.eq, where please note that the e is in capital. Okay, so twice x plus twice y comma 8. So whatever comes before the comma within this eq command, this twice x plus 3y, that constitutes the left hand side, and what comes after the comma, that constitutes the right hand side. We might as well write the same equation by writing on the right hand side 0 and on the left hand side minus 8. It's absolutely the same thing. Okay, so we'll just keep it in the same format that we had written in this markdown cell here. So this is our equation 1, and equation 2 similarly will be sim.eq twice x plus y comma 5. All right, so if we do a shift enter here, as you can expect, nothing really happens, because we have only set up our equations. What we can do is go back to this cell and display the two equations. Okay, and this display command, it can take more than one input. Okay, so I just say display eq1, eq2. All right, so that looks good. But again, so there is, you please note that there is a difference between the way that this is displayed here and it is displayed here. This is actually having some mathematical meaning behind it. So this is just a cosmetic thing here. Whatever is present in this markdown cell, that is just a cosmetic thing. Cosmetic means it is just a visual, like a writing. Okay, there is no mathematical meaning inherent to it, but here what you see, that has mathematical meaning. Okay, all right. I shouldn't say mathematical meaning, rather I should say mathematical life in it. Anyway, so we want to solve it. So the way we can solve it is to just use the linear solve command, so which is sim.linsolve. We also have a separate solve command, but I think because we are specifically solving linear simultaneous equations, this does the job well. Okay, so you note the syntax that I'm using here. So first of all, I am placing within square brackets the two equations that I need to solve. Okay, so if you have any number of equations, you need to put them sequentially in this kind of square bracket, and then you also have to mention which are the variables you are solving for. Okay, so you can write like this, x comma y, close bracket, and shift enter. So you can actually verify that the solution, this 1 corresponds to x and this 2 corresponds to y. So if you have x equal to 1, y equal to 2, it actually solves this equation. So twice plus 3 into 2, 6, that's 8, and 3 into 1 is 3 plus 2 is 5. Okay. Now we can have this in a slightly better fashion in this way. Okay, so we can say we can assign the solution variable to the output, but we have to do a little bit of a quirky Python thing here, so we need to put a comma here. Okay, let us not get into the details of why we need to put that comma right now. Okay, slowly as we learn things, we can delve deeper into those nitty-gritty details. But now if I press shift enter, well, nothing is displayed, as you can expect. Okay, so if we want to see what is present inside this solution variable, what we can do is we can display solution. But now okay, let's do a shift enter and see what happens. Okay, so you see this is 1 and 2. Okay, now suppose we want to extract only the first one. Okay, so the x solution and the y solution separately. So what we can do is we can do something like this. We can say x solution is equal to solution index 0. So unlike MATLAB, where the indexing starts from 1, in Python you have the indexing starting from 0. Okay, so that's similar to C, the C programming language. So the second solution will be given by solution 1. Okay, so now we can display this x solution and y solution. All right, now this definitely looks good, but I mean, if you're really demanding customer, you will perhaps have a little bit of a grievance that it is not really clear if I just write this display x solution, y solution. I mean, is this x or this is y? Of course, the way that you have set up the variables, it is definitely clear. But in a more involved situation, because you note that you will certainly not use symbolic Python to do these kinds of trivial calculations, which you can do orally, in fact. This is only for demonstration purposes, and later when you do 2D elasticity problems where there will be number of equations to solve simultaneously, it will perhaps be better if you can display the variable names beside the solution. Okay, so we can do this with a little bit of more effort and in a very nice visual way. So for that, what we'll do is we'll have to write a few more things, but once we do that, we can just keep on repeating the same thing. Okay, so I mean it's worth the effort. Okay, so let me demonstrate this. So what I'm going to write next maybe start looking a little bit completely alien, but I'll just explain. Okay, let me write down the thing. So from ipython.display import math from LaTeX. Okay, so I'll go into a little bit of explanation of that in a while. Let me just demonstrate what I mean to say. So display. Let me just quickly write it down and then I'll tell what I'm doing. Okay, let's do a shift enter. So this is what I wanted to show you. So x equal to 1 and y equal to 2. Okay, so this is again just a visual output. This by itself has no mathematical life of its own. Okay, it's just like typesetting. So what I've done here is that there is something called this IPython. Now, if you know a little bit of history behind it, or if you read up on it, you'll see this Jupyter Notebook is kind of a successor of something which was which people came up with earlier, which is called IPython. Okay, and the kind of successor to the Jupyter Notebook is something which is being used widely nowadays called the Jupyter Lab. But for our preliminary kind of work, we won't need Jupyter Lab. Okay, now many of the things that we are using in Jupyter Notebook directly derive from IPython. Okay, so this is something. So this special way of displaying our information, our solutions, and other things it is derived from that IPython thing. So that's what we are importing here. So this has a number of different packages within it, like sub packages within it. So two of them are math and LaTeX, and we are using that here. Okay, so let me not get too much into it, but what I am doing here with this R thing is this bit present, let me just highlight it, this bit present here within the single quotes, that's like the raw string of a LaTeX command, but it also has this kind of a blank entry which we fill it up with this format command. Okay, so this X solution is something which we obtain as part of our calculations, as you've seen in the previous cell here, and we can use that to fill it up here. Okay, so if you had filled it up here, if you had written X solution here, that would have just printed out X SOLN. Okay, that is something we don't want. We want to actually extract the value present within the X solution variable and put that here in a nice LaTeX format. Okay, and the same thing goes for the Y's. Okay, so I think this really helps us in clearly looking at the solution. Anyway, so this is what it is, and we will be using this a lot as we go along, okay, in our 2D elasticity calculations and solutions. All right, so with this, I think I have more or less covered what I wanted to cover in this very introductory, very basic Jupyter Notebook discussion. Please note that this is like not even scratching the surface okay, of the introduction of Jupyter Notebook, but I think I have more or less kind of covered what we'll be using quite a bit in the coming classes. Now there is another dimension to it altogether. Okay, so the calculus part, which we can discuss in another subsequent lecture. All right, thank you very much.